We're now going to test the features of our account class that we introduced in the previous several videos. And to do that, I'm going to go ahead and set a breakpoint here, and we're going to step our way through this program so we can see everything that's going on. Now, there are three local variables in main in this example, account 1 and account 2, which you see here at lines 9 and 10. And a little bit later on, we also have a deposit amount variable that has not yet been initialized either. So at line 9, we're going to create a new account object using the arguments Jane Green, which is a string, and 50.00m, which is a decimal literal value. And what I'd like to do is step into the constructor so that you can see the flow of control as this account object gets initialized. So I'm going to step in, and you can see we're now starting the execution of the constructor. We'll step into there, and then we'll step, and remember by default it's going to step over the execution of the property. Because this is an auto-implemented property, there's no set or get accessor for us to look at the source code for. It's all auto-generated behind the scenes. So I'll just step over that line. But for this account object that we're initializing, we can now see that the name property has the value Jane Green that was passed in, and we can confirm that that was the parameter value in this particular call to the constructor. Now we're about to execute the set accessor of the balance property, and to prove that, I'm going to right-click the property and say step into specific, and then select the set accessor here. So now we're in the set accessor with the value having the decimal value 50.00, and we're going to step down here and validate that. So the value is currently 50.00, which is greater than 0.0, and therefore this is true, and we're going to wind up going down into the body where we can now see that the value will be assigned to the balance. Now the value is currently 50. The balance currently has its default value of 0, which is about to be replaced, and you can watch down here as I step over this line of code. Now the balance instance variable has been updated, and even the balance property is showing the instance variable's value. So now we can return back into the caller, which was the account constructor. We can return back into its caller, which was line 9. And now, as we step over to complete that statement, account 1 exists. It's an account object, and it contains a balance of 50 and a name of Jane Green. Now, I want to walk through that process again here because in the case of John Blue, we're providing an invalid decimal value to initialize the account. So let's go ahead one more time and step in here, and we'll step over initialization of the account name, and we can see that the account's name is now John Blue. And we'll step into the balance. So let me right click the balance and select step into specific and the set accessor, and now we can see that the value is minus 7.53, which of course is not greater than 0. So as I step down here and I execute line 27, it skips all the way to the end of the set accessor, so the balance is still 0. And we can see that down here. There's no red, which also indicates that nothing was modified, so it's just maintaining its default value of 0. And as we now return back up the call chain, we go back to the account constructor, back to main, and as we step to the next line, we can now see that account 2 is initialized, but it's initialized with a balance of 0, not minus 7.53. So our validation in this case worked. Now let's continue on inside of main here, and at lines 13 and 14 we have a console.writeLine statement that's going to access the account 1 object's name property and the account 1 object's balance property and display their values in a string of output. Now, of course, the account 1's name is Jane Green. Notice if I hover over account 2's name, we get a different value, thus showing you that each account object has its own name object within it. And similarly, if I hover over account 1's balance, I see that it's 50, whereas if I hover over account 2's balance, I see that it's 0. And again, that proves that every single account object has its own balance. Now you'll notice that the string interpolation expression here on line 14 has a new feature in it. Following the value that we'd like to insert into the string, we have a colon and a so-called format specifier. C is the format specifier that represents currency. And depending on your own locale, when you run this program, the currency value may be displayed differently on your machine. So let me step over this line of code for a moment and just go to the output. And you'll see here when I look at the output window that it's showing $50.00, which is in the US locale, the United States locale, the way that we format the dollar amount, $50. If you're running this program in a different locale, you may well see a different format. So for example, if your country uses the euro, you'll see a euro symbol. And if your country does not have dollars and cents the way the United States has, you may not have a floating point portion to the number that gets displayed. It may get rounded to the closest integer, for example, as is the case in Japan. So the formatting that you see here is locale specific, and therefore your output on your screen may look different from my output on my screen. So let's go back over here. So we've seen now account 1's name and balance, and we're going to do the same thing here for account 2. So I'll step over that statement, and we can see clearly that John Blue's balance is $0.00. Now the next thing we're going to do is deposit some money into the account 1 object. So we're going to prompt the user for input. Then we're going to read in a line of text and pass it to the decimal types parse method, which will convert that string into a decimal value that we can assign to the decimal variable deposit amount. Now, I'm assuming that you're going to type a proper floating point number. If you type in an invalid string of any kind, this line of code could generate an error message at runtime and cause the program to terminate. So let's say we're going to deposit $23.75 into the account. If I hit enter, it's now waiting for the next line of code to execute. We can see that deposit amount is 23.75 at the moment. We're going to display that as a currency value, indicating that we're about to deposit that amount, and then we're going to pass that to our deposit method to increment the value in the account object. So I'm going to step over lines 21 and 2, and I'm going to step over line 23 as well to just show you the deposit executing. And now if I look inside of account 1 here, we can see that the balance changed from $50 to $73.75, so $73.75. Now to prove that we didn't modify account 2 at all, we output both accounts' names and balances once again. So I'm going to step over both of these lines and go to the output window where we can see Jane Green's balance changed from what it was up above, but John Blue's balance is still 0.00, further emphasizing the fact that these are two different physical objects in memory, and that when we invoke a method or property on a specific object of class account, it always goes to the correct object to get the corresponding data or set the corresponding data respectively. So now we're going to input a deposit amount for the other account object. So we'll prompt the user for input. We'll read in a line of text and convert it to a decimal. And we will now wait for that. So let's say we're going to put $123.45 into that account. It's now waiting for me to continue executing by displaying the deposit amount and depositing into that account. And if I stop there, you can see that account 2's balance just got modified because we added a value to it. And now once again we're going to display the two balances, and as I switch back to my output here, we can see that Jane Green's balance remained the same from the preceding output, but John Blue's balance was indeed incremented by $123.45. So we've now seen the full version of our account class. Of course, you could go ahead and modify this example to add a withdraw method. And in fact, you know what, let's do one other thing. I'm going to run this program again, this time not in debug mode, and I'm going to do that on purpose to enter a negative deposit amount. So right now it's expecting me to enter a positive amount, but if I say minus 10.45, for example, and hit enter, you'll notice that the balance was not modified because this was an incorrect balance. Also notice how it was formatted for output. This is a common accounting way to represent a negative number with parentheses surrounding that number, and that's part of the currency formatting capability that we're using in this example. So all that formatting is defined for you. Now there are lots of different format specifiers that you can use in a scenario like the one that we're doing here, for example, at line 27 for currency format. And let me go ahead and switch over to a PowerPoint slide for a moment. So you have uppercase and lowercase c for currency. You have uppercase and lowercase d for integer whole number types, and then you have various other format specifiers as well. So, for example, n represents in the United States just a floating point number with 2 digits to the right of the decimal point by default. The e or lowercase e is for scientific notation. The f or lowercase f is for floating point numbers with 2 digits to the right of the decimal point. G or lowercase g chooses between scientific and floating point format based on the magnitude of the value. And then we have x and lowercase x for hexadecimal formatting of integer values.